Hey there YouTube, it's Paul here from the engineering. A noisy large piece of machinery which is used to generate cool water, and that's used to provide air conditioning in buildings. You can see on the animation here the chiller down in the basement. You can also get chillers up on the roof here as well in a slightly different design, but let's not get too involved in that right now. In this video we're going to be looking at what's happening inside this plant item and how it produces the chilled water for the air conditioning, and also how it rejects the heat as well. So in the chiller, the chilled water which is produced in the evaporator, when it leaves, it's leaving, you can see here, it's leaving at about 6 degrees Celsius, and this centrifugal pump here is then pushing that water around the building, where it enters into these AHUs that collect up all the unwanted heat within the building, and this heat is then returned back to the chiller, and it's returning here about 12 degrees, sorry. By the time it leaves the chiller again, it will have given up 6 degrees worth of Celsius of heat, so it's leaving at 6 again. So it leaves at 6, comes back at 12, and this cycle repeats and repeats and repeats. Now the heat that leaves this circuit here is transferred via a refrigerant over to the condenser. Now these two systems are completely isolated from each other. There is just a refrigerant which transfers the heat between these two circuits. So the heat that is picked up in the condenser is then pushed in another circuit up to this pump here, the centrifugal pump, and that is pushed then up into the cooling tower, where the air is forced by a fan inside, and that dissipates and rejects the heat from the building. So this water then returns at a cooler temperature. You can see it's being sent up at 32 degrees Celsius, and it's coming back at 27 degrees Celsius. So this water returns back to the condenser, ready to pick up more heat from the chilled water system and reject the heat from the building. Now, chillers come in all shapes and sizes and thermal ratings, and that really depends on which passes around each of the 4 components and transfers that heat. The secondary circuit, you need the heat from the building that's being collected, sent to the chiller, and then back to the building. The third and final circuit that you meet, 4 components, these are the 3 circuits. You might be wondering about what's happening inside here. So then leaves again. It does not leave these tubes. The refrigerant passes through, picks up the heat, and it just transfers that static pressure here, and it's pushing that refrigerant to not leave. It enters, passes around these tubes, and then leaves again. The refrigerant comes in, is just expanding that refrigerant, giving it a greater ability to pick up heat when it gets into the evaporator there. So these are the 4 main components and the 3 main circuits you need to know about. They will appear in every going around a chiller is a little bit difficult, so what I've done is created this 3D model here, and this will allow us to just go around the chiller. I've been in further videos, but for now let's just apply each of the 4 components and try to work our way around the chiller to see where each of these are actually located. Up on the top there, with the electrical motor mounted on the back there. Now down here we've got the condenser. That's this large tube or cylinder here with the inlet and outlet. Turn the chiller around a bit, and we'll see here we've got the expansion valve. The expansion valve just located on the bottom there to the condenser. The water will enter and leave, and you can see in some of the tubes inside there. So that's the condenser. the expansion valve, where the refrigerant passes through this and into the evaporator, and that then leads through the evaporator there. So you should have written down the 4 main components and the 3 up this photo here of a real life chiller, the McQuay chiller, and just apply your knowledge here. So take a few moments. Can you tell me what is this cylinder here? And if we look at the back of this chiller, there's the condenser again there, and you'll see this tube, this pipe coming along from there, because that chilled water costs quite a lot of money to produce, so you want to retain as much coolth into that water as possible. So as it enters into the compressor, the chilled water is entering and leaving here. It's entering at about 12 degrees and it's coming back out at about 6 degrees Celsius. You may have noticed on this system here, on this design, the pipe, or the chilled water, is entering and leaving. It's entering through one end and leaving through the other end, whereas our design has the pipes coming in and out. That is fine. That is just a different type of design. We'll go into much more detail about that on another tutorial video. And as you can see here, the pipes actually are entering and leaving on the condenser just on one side there. So this is a 2-pass system, but again, don't worry about that. For this video, you should just be able to you should be worrying about what these 4 components are. Actually, you shouldn't be worrying. You should know now what these 4 components are and the 3 systems within them. If you don't know them completely off by heart yet, that's fine. I'd recommend going back through the video just to learn it again and kind of get that fixed into your brain, because these are essential knowledge if you want to get into the industry for this.